actually from the surface of the ocean down to the deeper part of the ocean. The first one is the solubility pump. So simply CO2, just gaseous CO2 gets dissolved in seawater, just like oxygen and nitrogen. Gets mixed in by waves, water movement. And CO2 is more or less soluble as water gets colder. More, right? So as the water gets colder, the more gas it can hold. So in the polar regions, that water is going to be richer in CO2. And what happens to water at the poles? Where does it go? It sinks, right? It gets cold, it gets salty. So that water at the poles gets moved down to the deeper part of the ocean. So that's the solubility pump. It's very simple. CO2 more soluble in colder water. Colder water gets more dense. It gets saltier when sea ice forms. And that CO2 gets pushed into the deeper part of the ocean at our polar downwell regions. So that's the solubility pump. The other pump is this biological pump that ties up phytoplankton and photosynthesis and respiration and how carbon gets cycled. So the idea simply is that, big phytoplankton, especially things like coccolithophores that make the calcium carbonate tests, when they photosynthesize and make these big blooms, a lot of those phytoplankton will die. And a lot of those dead phytoplankton, especially those calcium carbonate tests, actually sink to the bottom of the ocean. They don't get eaten necessarily. So a lot of that phytoplankton biomass and a lot of the carbon that goes with it actually gets sunk down into the deeper part of the ocean and gets sequestered down there. It doesn't get essentially metabolized by consumers and then respired back into the atmosphere. Quite a bit of it gets sunk into the deep sea. So that's the simple biological. Sorry? Yep, I mean, it could be they're out of nutrients, like when the spring bloom collapses. And because there's so many of them, not all of them get eaten. And a lot of them, instead of just decomposing up here in the upper part of the water column,